In this video, we'll be having a look at the following question in limits. Does the following limit exist where x and y approach 0, 0, and look at the limit of 5xy divided by 2x squared plus 3y squared? If you like, you can have a go at this question yourself before looking at the solution. If you want, can pause the video if you wish. Okay, let's have a look at the solution now. So I'll let the function f of xy be equal to this 5xy over 2x squared plus 3y squared quantity. And observe this function is defined for all x and y apart from the origin 0, 0, because 2x squared plus 3x squared is always at least 0, but it's only equal to 0 when x and y are equal to 0. And another thing we can observe is if we try to plug in the 0, 0 straight into this function, we get the 0 over 0 indeterminate form. So this doesn't tell us whether or not the limit exists. Okay, so what I'll do is look at two different sequences of coordinates and see how that can be useful. So the first sequence of coordinates I'll look at is the sequence A1, A2, A3, and so on. And this is where AK is defined to be 1 over k, the x coordinate, and 0, the y coordinate, for all k at least 1. So the y coordinate is fixed at 0, and the x coordinate will be 1 over k, where k is at least 1. What we see is these coordinates will limit towards the origin because the y coordinate is fixed at 0, and the 1 over k will also approach 0 as k goes to infinity. And now we'll look at what happens to f when we apply the function f to these coordinates. So f of ak is equal to f of 1 over k and 0. And when we substitute into the function, we see since y is going to be 0, the whole function will be 0. And also see that we can see the function will be defined because the denominator is positive, because we have 2 times 1 over k squared, which is positive, and then we have zeros here. So f of ak will always be 0. So what we see is that the limit as k goes to infinity of f of ak is equal to 0. So if we visually look at this, it means, so the points will look something like this. So the points ak will approach the origin, and we approach the origin. As we approach the origin from this direction, f will always be 0. So this means another thing we can see from this is if we want the limit, if we want this limit to exist, it has to approach, f has to approach 0 from all directions. So no matter which direction we take, we want it to reach 0 from all, limit to 0 from all directions in order for the limit to exist. But so we'll have a look at whether that's true or not. So we now consider the sequence b1, b2, b3, and so on, where bk is equal to 1 over k and 1 over k. So x and y coordinates are the same now for k at least 1. And we see again, as k goes to infinity, we limit towards 0, 0, because 1 over k will go to 0. This is the same as this diagram approaching the origin from this 45-degree angle direction. And again, we'll look at what happens to the function f. So if we look at f of bk, this is f of 1 over k, 1 over k, and we substitute all the 1 over k's like this. And eventually we'll see we have 1 over k squareds here, which cancel out to give us 5 over 5, which is equal to 1. And what this means is that f of bk is always equal to 1. So it's going to limit. It's the same as saying it's also going to limit to 1 because it's always 1. And we also recall from earlier that the limit of the b's is 0. What happens is, so on this green line over here, f will always be 1, but these red points over here, f of ak will be 0. So what happens is we approach the origin from 2 different directions. The 2 limits are different for the f's, and that means we can finally conclude, which is here, we can conclude that the limit does not exist of the f of xy. So we found 2 sequences of real numbers with limit 0, 0, but the corresponding function values of those sequences have different limits of 0 and 1. So that's why the overall limit does not exist. That concludes the solution for this limit question. Hope you enjoyed this video. Thanks for watching, and I'll see you next time.